Hey everybody, welcome back to Pre-Algebra with Mr. Mac. We're looking at day 6, lesson 6, and today we are going to look at linear functions specifically. So we've been talking about functions. Functions happen when each domain has exactly one range. So there's lots of different types of functions. Today, we're focusing on those linear ones. So I think the easiest way to identify a linear function might be by recognizing that it makes a line. So you can see a straight line here, right? So each x value in this line has only one range. So if you go up, no matter where you're at on the x, you can only hit it in one spot, right? So being that it makes a function, each domain has one range, and the fact that it is a line, then it is a linear function. We have to satisfy both of those things. So looking at the two pictures, these are both functions, okay? The vertical line test tells us that on the left, the wavy one, it's still a function, only crossing one spot, but it's not a line. In order to be a linear function, it has to both be a function and be a line, which the image on the right satisfies. Now you might notice we've been talking a lot about proportional relationships. The line on the right does not go through the origin, so it is not proportional, but yes, it is still a linear function. Each domain has exactly one range, and it is a line. Looking here, this is not a function, so it can't be a linear function. You would notice if we did a vertical line test right here, it would cross in two places. If I did here, it'd cross in two places. So in this case, each domain does not have a single range, which means it is not a linear function. Two reasons: not a function and not linear. This is maybe the trickiest one. You might be looking down here already and it says not a function. You'll be like, bro, that is totally a line. And I would agree. It totally is a line, so it is linear. However, domain -2 right here has a bunch of ranges. It has all the ranges. And each domain has exactly one range. So this can't be a linear function. It's linear, but it's not a function because domain -2 has all those ranges. And you might remember back in the day when we were doing slope, back we were still up in 109 before all the Rona, we would say there is no slope for this line. And that's because it's not a function, so it's related. Some stuff that we've already done. So I think by looking at a graph like this, it's pretty easy to tell if it's a linear function. Like, is it a straight line? And is it a function? Yes. Here's what we're going to be looking for in tables and graphs, though. See this right here? This is what I would call the common difference. And there's also a common difference over here, which means that we have slope. If there's that constant relationship between the y and the x like that, remember slope is y to x. Every linear function has this, what I'm going to call a constant rate of change right here. And remember, m is slope is a constant rate of change. Okay. So same kind of thing. So when I'm looking at tables, I'm looking for that constant rate of change. What gets a little tricky though, beware, is if on the left side here, if that's not all happening the same, you've got to calculate that slope all over and over to make sure. Luckily, these are all going up by 1, so this side has to all do the same thing. But like, let's say, here we go. Let's say our table, our x's went like -2, 0, 2, 4. Or no, that's 0, 1, 2. Okay? And let's say it goes through the origin, and this goes 2, 4. Well, there's no -1 right there, right? So right here, +2, that's good. This would have to be -4, which looks like that's a +4. However, there's that -1 missing, which would put it at 2, -2, which is that common difference of 2. So you got to look both sides of the table to establish that common difference or that slope. So let's check this one out. If you just look at the graph, whoops, one sec. I got you. All right, if we just look at the graph, that's Soldier Boy's favorite graph. It makes the U, okay? Now let's look at the table. We've got that x happening at a common difference, cool. But check out how our y is changing. -3, -1, +1, +3. That's not at the same rate, which means not a line. And you might remember, to be a linear function, it has to both be a line and a function both. So you're going to want to be looking for slope, which is, remember, how the y changes over how the x changes. This doesn't have a slope. It's constantly changing, right? It's getting steeper, 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 steeper. That's not a line. All right. So a really nice way is to see if it's in a linear equation. The one you're most familiar with looks like this. Y equals mx plus b. Another linear equation will look like this format. And then one that you probably will not see a lot yet, you will see it a lot next year, is there. So if you look here, see how x, y are on the same side? That is right there. That's called standard form. It can also be written as slope-intercept form. Now, over here, you might notice there's not an x to the first power and y to the first power in any of these. This y is in the denominator, which actually means it's a y to the -1. This x is cubed, and we have an xy term. You're going to be looking for just an x and just a y term, okay, to the +1 exponent. So one thing you can do is just test out your points. So if we're given this first equation, we've had some practice making an xy table. So you can start doing stuff if y is, I like -2, 0, 2, let's say. So if I go to y and I put in -2, I get -4 plus 4 is 0. Okay, put in 0 for y, I get 0 plus 4 is 4. Put 2 in for y, I get 4 plus 4 is 8. Do I have a common difference on both sides here? So +4 plus 4 plus 2 plus 2. Yes, I have a slope. Also, if I go down here to my equation and I subtract 2y from both sides, you'll see it in the red there, I get x minus 2y equals 4. And that's that standard form, x to the first power, y to the first power we saw on the previous page. All right. So once you have those points, they tested the same points as me actually. You can go and plot those points and note that that'll make a perfect line because, yes, it is a linear function. Here are some non-examples of linear functions, and let's go over how we know. Instead of an x plus y to the first power somehow, we have an xy term. And if we substituted some stuff in, let's say xy, and I have 2, 0, 2. When x is -2, y would have to be -2. When x is 0, y would have to be, there's no answer actually. 0 times something is 4. There's nothing you could do. And then, so yeah, no common difference. Disproved it right there. Let's look at our ordered pairs on the top right there. And I like to put that in an xy table, least to greatest. So -3, -1, 1, 3, 5. Cool. So do you guys see that +2, +2, +2, +2? So we got a common difference on the x. Cool, cool. Our y goes 10, 9, 7, 4, 0. So -1, -2, -3, -4. This, while a pattern, not a common difference, okay? So that's why that is not a linear function. Let's check out, this is not an x to the first power. X is the exponent. But what I like to do still is I like to test out the -2, 0, 2. Let's see what happens. So when x is -2, you actually might not know this yet, but that'd be 1/4. 2 to the 0 is 1, and 2 squared is 4. So this went +3/4. This went +3. I don't have a common difference happening in my outputs, so that is not linear as well. So we have reasons on all these why they're not linear. Thanks for watching, guys. Want to let you know I miss you. As you're doing the homework, I'm allowing you to change mistakes, so make sure you're going in and changing those mistakes so I can give you some credit. When you have those questions, I have office hours. Use those office hours. Hit me with those emails. Now, one thing I need you organizationally to do. If you do something after it was kind of due, so I'm doing grades like every Friday. If something wasn't done, I don't put it in. I need you to email me when you've done it because it's kind of impossible with all these different assignments and all the different classes to go check everybody. But if I know what I'm looking for, I can do it really easy. So if you finish it, make sure you email me that you finished it after the fact, I can go back in and hook you up. And just know I got your back. Anything you need, you let me know. But you gotta ask. So, miss everybody. Hope you're doing well.